Hello students, welcome to this new session. In this particular session, we will discuss the characteristics of a standard unit and thereafter we will discuss the advantages of SI. As I have told you, SI is the system which is the most preferred one. So why we opt for SI system? There are some advantages naturally. Those advantages will be discussed. But before that, we need to understand the characteristics which a standard unit must possess, right? Like, let's discuss point by point. It should be well defined. Any standard unit must be well defined. Its definition must be approved and must be understood by all. It should be acceptable to the entire community, right? So, any definition should be of a standard unit must be well defined. There shouldn't be any ambiguity in the definition of the standard unit. So, that's the first characteristics which a standard unit must possess. So, it should be well defined. Second is, it should be of suitable size. We have discussed in the earlier section that a physical quantity can be represented by n into e. X is the physical quantity, n is the numerical value of that physical quantity, and u is the size of the unit. I am talking about the size of the unit. It should be suitable. It should be neither too small nor too large, right? So it should be of suitable size. It should be easily reproducible. It must be easily reproducible. It means that, like for the definition of kg, what we have discussed was iridium platinum cylinder is kept at the International Bureau of Weights and Measures at Sèvres near Paris in France, right? So its prototype is to be reproduced at different places. It should be easily reproducible. That's the meaning. So any standard unit must be easily reproducible. Fourth, it shouldn't change with time. With the passage of time, the definition of the standard unit must be constant. It should be relevant at all times. It shouldn't change with time. It shouldn't change with place. At every place on earth, its value or the relevancy of the definition should remain same. So it shouldn't change with time. It shouldn't change from place to place. One of the very important characteristics which a standard unit must possess is that it shouldn't change with the change in its physical conditions. When I am talking about physical conditions, what I mean is that temperature, pressure, etc. So even if there is a change in temperature, pressure, the definition or its relevance shouldn't change. So this is one of the very, very important characteristics. Should not change with physical conditions like temperature, pressure, etc. So these are some important characteristics which a standard unit must possess, right? So a standard unit must be well defined. It should be of suitable size. It should be easily reproducible. It shouldn't change with time. It shouldn't change from place to place. It should not change with physical conditions. Right? So these are the characteristics of a standard unit. Now let's move on to the next article. So, advantages of SI. We have discussed various systems of units starting from CGS, FPS, MKS and lastly SI. So now we will discuss why we prefer SI system. So there are 4 advantages basically. We will discuss one by one. The first important advantage of using SI system is that It is a rational system of unit. It is a rational system of unit. Now rational means logical. So it is basically a logical system of unit. You can say like that, rational system of unit. I'll give you an illustration that will make your concepts much clearer, right? Rational or logical, what's the exact meaning of this? Like, take the case of energy. Energy is a physical quantity. You've heard about its various units, isn't it? Energy, it can be measured in watt-hour, it can be measured in joule, it can be measured in calorie. There are various units. In SI system, we use only joule as the unit of energy. Energy can be of any form. It can be chemical energy, nuclear energy, electrical energy, heat energy, any form of energy. Its SI unit would be joule. So in SI, only unit which we assign is joule. Be any form of energy, only joule is used as the SI unit. Right? On the other hand, consider NK system. NK system. Let me give an example. In NK system, heat energy, it is measured in calorie. Then electrical energy, it is measured in watt-hour. So what I mean to say is that both are energies only, both are the different forms of energy. But in NKS, we are using different units for different forms of energy. So that is quite irrational or illogical. So it is preferred to assign only one unit to a physical quantity. Right? So that is why SI is said to be a rational system of unit. You can consider another case as well. In MKS and CGS, we make use of either absolute unit or gravitational unit. That also we'll discuss in the later section. So there are two types. In CGS or MKS, we can either make use of absolute unit or gravitational unit. For example, the absolute unit of force in MKS is considered to be Newton, while in the gravitational unit is considered to be kilogram force. So again, same quantity force, but having different units, Newton as well as kilogram force. But in SI, only one unit. And the unit of force is any type of force. It is Newton. So that's the reason why SI is said to be a rational system of unit. So this is the most important property or the advantage which SI system possesses over other system of units. Right? So that's the first point. Second is, SI is a metric system. Obviously, CGS and NKS, they are also metric system. But SI is also a metric system. Metric system means it can be expressed in powers. The multiples and submultiples actually can be expressed as powers of 10. So that is, SI is a metric system. So the multiples and submultiples in SI can be expressed as powers of 10. Here I must tell you, CGS and NKS, they also are metric system, right? Third, first is rational system of units, second is metric system. Third is, SI is closely related to CGS. Okay, I'll give you an illustration again. Means SI unit can be easily converted into CGS or vice versa. Means CGS unit can be easily converted into SI. This is a very important advantage. I'll give you an example. Like the SI unit of force is Newton. The CGS unit of force is time, right? So we can easily convert, or rather we can easily find out the relationship between them. We are aware force is given by mass into acceleration. We'll discuss this also. This follows from Newton's second law, right? So anyway, SI unit of force is Newton, right? So 1 Newton is equal to 1 kg. SI unit of mass is kg. Acceleration is meter per second square, right? While CGS unit of force is dyne. So force 1 dyne. CGS unit of mass is 1 gram. Here I must mention, in a given relationship, in left hand side if you are using SI system, then in the right hand side also you need to make use of SI system only. You need to make use of any one system, either SI or CGS, right? Be consistent. It will be absolute stupidity on your part if some quantity is expressed in an equation in SI and the other physical quantity you are expressing it in some other system of unit. Don't do that, right? Express all the physical quantities in any particular system of unit, right? So in CGS it is dyne, in CGS mass is measured in gram, and in CGS acceleration is measured in centimeter per second square, right? You remember CGS length it's measured in centimeter, time it's measured in second only. So let's find out the relationship in these two. So 1 Newton is equal to, now let's convert it. 1 kg is 10 raised to power 3 gram. We are all aware of it, 1 kg is 1000 gram. 1 meter per second square, no need to change second, meter is 100 centimeter, so it will be 10 raised to 2 centimeter per second square. What do we get is, 1 Newton is 10 raised to 5 gram centimeter per second square, and gram centimeter per second square is dyne. Therefore 1 Newton is 10 raised to 5 dyne, right? So this is how SI can be easily converted to CGS, or CGS can be easily converted into SI. 1 dyne in turn may be written as 10 raised to power minus 5 Newton, right? I'll give you another illustration as well. So we can consider the case of energy as well. I mean, SI unit of energy is joule, while CGS unit is erg. So we can easily get the relationship between joule and erg. So again, it's very easy to convert SI into CGS and vice versa. So let's deal with that. Now energy, or rather work, it is force into distance, or rather work done. It is force into distance, or any formula you can use. It can be in the form of kinetic energy. I mean, it is the energy caused by a body due to its motion, which is half mv square, or by virtue of its height or position, a body possesses potential energy, that is mgh. So by using either of these formulas, you can easily get the formula for the joule in terms of basic units. So it is actually force into distance. So force is Newton, distance is meter. So 1 joule, it is Newton meter. Now what about CGS unit? It is erg, and it is Newton. CGS unit of force, just now we have discussed, it is dyne, and CGS unit of distance, it is centimeter. Now we can easily convert, or rather we can easily get the relationship between joule and erg. 1 joule is equal to 1 Newton. 1 Newton, as we discussed in the earlier section, it is 10 raised to power 5 dyne. Multiplied by 1 meter, as you are aware, it is 10 raised to 2 centimeter. We can write it, isn't it? So 1 joule, it would be equal to, base is same, so the powers gets added up. So we get 10 raised to 7 dyne centimeter. So 1 joule, it would be equal to 10 raised to 7, and dyne centimeter is erg. So simple. This is how we can get the relationship between the SI and the CGS unit of energy. So 3 advantages we have discussed. SI is a rational system of unit, SI is a metric system, and SI system is closely related to CGS system. There is another important property, fourth, which is SI is a coherent system of unit. It is again a very, very important concept. So fourth advantage is it is a coherent system of unit. SI is a coherent system of unit. In the previous lecture also, I've stated the definition of coherent system. And I've told you, MKS is also a coherent system, but in mechanics. MKS system is also a coherent system in mechanics only. Only in that particular branch of physics, MKS is a coherent system. But SI is a coherent system in any branch of physics, right? Coherent means, co means with, together. So system is said to be coherent if the derived units of that system is obtained either by multiplication or division of its fundamental units without the introduction of any numerical factor. So that's the definition of coherent system. For example, again take the case of force or energy. Newton, we have discussed, it's given by kg meter per second square, isn't it? Just how we have discussed. Joule, it is given by kg meter square per second square, isn't it? So this is the derived unit, which is obtained by either multiplication or division of the basic units without introducing any numerical. Here I am not introducing any factor like half, 3, 7, 8 by 9. I am not introducing any numerical factor, any fraction, any number. So whenever it happens that a derived unit is obtained either by multiplication or division of the fundamental units without having the need of introducing any numerical factor, then that system is said to be a coherent system. So students, please remember, SI is a coherent system. MKS is also a coherent system, but in mechanics. So these are the advantages of SI. Hope you have understood the topic. Please recap it thoroughly and revise it properly, right?